Hi, welcome to this video for Leetcode 142 linked list cycle. The goal of this question is to actually find the beginning of where the cycle starts, so of a linked list, I should say. And the other thing that you want to know is that this particular question involves a technique called fast and slow pointers. It's very important to know because when you have something like a linked list and you want to detect a cycle, you always want to use this technique. First, a little basic thing about what a linked list is. It's a node that has a pointer to the next node, and then at some point perhaps that node points to null, or at some point maybe instead that node points to another node, and then you have a cycle. Like here, you can just keep going like this over and over again. I think right now it's useful to think about an analogy of what would happen if you knew for a fact that you were in a cycle. So what is a good way to think about a cycle? Let's think about a racetrack, like a 400 meters racetrack at the Olympics. So this is definitely a cycle, continuous. And suppose you are a person who runs 10 kilometers an hour, okay? And you're racing Usain Bolt, who runs 20 kilometers per hour. Now, suppose this race would go on for perpetuity until Usain Bolt catches you. Now, because Usain Bolt runs twice as fast as you do, and suppose you both start at the same place, at some point Usain Bolt will catch you. I think this kind of analogy is easy for most of us to kind of visualize and understand that if you're on a track, one party runs twice as fast as the other party. At some moment, they will meet. So if you have a linked list and you want to detect a cycle, if that linked list doesn't ever end in null, then you can keep looking for that cycle. If it does end in a null, that means you know the cycle doesn't exist. It's worth pointing out that question 141 on Leetcode is to simply detect a cycle, and 141 is to detect a linked list cycle, and 142 is to detect the starting point of that cycle. So I think right now it helps to take a real quick look at the code, and then we will go ahead and start on the example of running through what would happen. So again, you have a slow pointer here, you have a fast pointer here, and as long as the fast pointer is not null and its next is not pointing to null, meaning it hasn't ended, then you can iterate, you can step through and kind of move the pointers forward. And as we mentioned, the slow moves forward at one step, and the fast moves forward at 2 steps. And at some point, they should meet. If they don't meet, then there's no cycle. If they do meet, what you want to do, if you take a look at this type of linked list cycle, is that, for example, what might happen is you might have the fast pointer and the slow pointer, so after a few cycles, end up at this step. And then what you want to do is see if you move head forward one step at a time and slow one step at a time, where do they end up meeting? Because they will always end up meeting at the starting point. The question is just how long it takes. So I think if you understand the general concept of the code, doing a quick step through will really help us to see what is exactly happening with both a fast and slow pointer. So let's take a look at that right now. So in the beginning, you start at the same place for the slow and fast pointer. And then when you move forward, what's going to happen is slow moves forward 1 step, fast move forwards 2 step, right? So you see, we'll just write it right here. Fast is 2x, slow is 1x. All right? And so at the next point, you'll see that fast move forwards 2 and slow will be at where fast currently is. So if I show you the next step, you'll see that that's exactly what happens. And then we continue this step through again. And then again, fast move forward 2 spots, slow move forward 1 spot. So they're almost about to catch each other, and they will at the next step. I guess it's very important to note that when you're moving these things through, you want to make sure that you compare the value of what the node contains. So usually you don't have to compare the value of the node. You just compare to see if they are the same node. So once you achieve this particular spot, it goes back to what we talked about earlier, where you have the head at this place. So once these two meet, what you want to do is, so when fast and slow meet, you want advance slow 1 step at a time and head 1 step at a time until they gradually meet each other. And that's exactly what's going to happen if you take a look at what we drew earlier, and we actually just try to take that 1 step at a time, right? So then head will be here, slow will be here, and then head will be here, and slow will meet head, and then you end up returning this node. Okay, so that's Leetcode 142, linked list cycle, where you find where the start of the cycle is. Hopefully this video helps you think about cycles with a better analogy, and also drawing it out helps you see what you're supposed to do when you have this kind of question. Remember, this requires a technique called fast and slow pointer. And when you see a lot of linked list questions and it's asking you about cycles, this is probably the first technique to try to think about. Okay, that's it. Thank you so much.